I've just quickly doing a AMD Ryzen Master control software video. Now this video is just going to be a quick pop at AMD because their software is crap and doesn't work. The design of the software is like it's been done by somebody who has no experience of electronic engineering. The coefficients and deviations to voltage, currents and amps, and how that affects the performance and the heat produced by the processor. While they have some sort of idea of, add volts makes it faster, that is really a prehistoric single core or maybe dual core old phenomenon, and it doesn't actually transfer over to multi-cores. Now I have a Ryzen 7 which is 8 cores and 16 threads, so let's have a look at some really basic maths here, because this all goes down to Ohm's Law. Now, if I have 1.3 volts at 100 amps, I make 130 watts. If I have 2.6 volts at 50 amps, I have 830 watts. Now, as you probably gather, I've just changed my voltage, halved my ampage, and got exactly the same result. The same thing happens in reverse as well. I can go down to 7.5 volts and go to 200 amps and still get the same result in wattage. So when they design the algorithm, as they say, which takes in complex thingies of hoo-ha to do whatever, that rubbish is really nice to, I used to call it technobabble. So anyway, voltage increases on processors is not proper way of doing it. Don't do it. The voltage increase on processors for overclocking was a thing done in the 90s and 2000s, because the resistance on the size of the dies and gates was more than the specifications. So to do it then, you had to add more voltage on it to move the gates quicker, to increase the megahertz and the coefficients. So yeah, that was great back then, but with multiple cores it actually comes out completely differently, because the injection of voltage or power, as in force, really does make a difference to the resistance on across the silicon. So as you get the more gates and they're smaller, your resistance becomes lower. So the more voltage you put in is literally going nowhere. Now the voltage then is the wattage, or what you're using, the energy, is a combination of voltage on one side and ampage on the other side. So what you can do is you can keep your voltage exactly the same but push up your amperage, and that amperage then will give you the same energy watt output. It's always been the same. Ohm's law doesn't change. Half the voltage, double the amps. Double the voltage, half the amps. It's up to whichever way it works, you still end up with exactly the same result. So what they've done with this algorithm is took someone who hasn't got a clue, obviously, and then went on, well, maybe that's how you do it because that's what we've seen, but we've not had any, more newer information on multi-cores, so we'll just do it exactly the same as what you did it to single and dual cores, and obviously the older, larger gates. So the problem is that what they've done is they've created a power curve to relation to temperature, case temperature, and they made it so that you get more power as long as your temperature case lowers down. That's one side of it, and then there's an amperage change, which then changes your clock, your clock cycle speed multiplier. So what they've done is they've made this kind of like hashed together software on rough dynamics that actually doesn't work. So what you don't need to overvolt when you're on idle. that's just complete rubbish. But you don't need to overvolt at the higher levels either. All you need to do is actually increase your amperage, and that will increase the energy going to the processors, and unless there's some mystical knowledge that magically at a certain speed that the resistance level doubles or something magical like that. But either way, we all know that lowering your voltage makes for a cooler processor, and for cooler processors we have less noisy fans and we have more comfortable work environments. So if you wanted to be uncomfortable and buy AMD's algorithm threes to death, because they actually use their benchmark is ambient at 5 degrees. So if you can sit in 5 degrees without dying for a day, then well done at AMD. That's really good of you. So what you need to do is recalculate the thermal efficiency and resistance across a multiple cores to get a mean, so that you know exactly what your resistance behavior is at certain clock levels. Once you've done that, then you can go, well, is it wattage that we need, or is it current that we need? Because it definitely isn't voltage, because voltage is the bane of overclocking, because it generates too much heat. Now the maximum threshold and resistance to the speed, the megahertz frequency, is really the coefficient that you need to idealize and bring down the voltage, because I can get over 5 gigahertz on a 1.2 volt on a 1.2 volt clock, and because I'm such low voltage, the overclock is there, and the headroom's there, so I can go all the way up to 5 gigahertz at 60 degrees Celsius, and most people are going, well, that's like my light gaming or something like that. So and then 80 degrees on their loads, and yeah, I can get thermal runaway with the algorithms. They're really badly designed. Whoever done them obviously is clueless. They come from a different time period and from a different background. I mean, if I wanted a chair made out of wood, I'd ask a carpenter. If I wanted one made out of iron, I would ask a ironmonger, but I wouldn't ask the ironmonger to make the wooden chair. It really doesn't work well. So you need to obviously get your electronics engineers and your software engineers into a room together, and the technical quantum physicists that you should have employed with your business to look at the thermodynamics and the actual current dynamics of the processors at different regions, and obviously aim to actually bring down the voltage, not up the voltage, because retards will up their voltage. And I'm sorry for whoever I just insulted, because obviously a lot of people think that upping the voltage really works to stability. It doesn't work like that, unfortunately. You can up your amperage, which is probably a much better choice. But then obviously with AMD that is not really 100% your issue there, because that's down to the VRMs built onto the motherboards about the supply of amps, because the more amps you can supply, the more you can lower your voltage down. And with minuscule voltages as they are, it really is a kind of a quandary between, well, what do? We have to have a specification there for all the chips to run, and the software algorithm needs to be wrote correctly, but you need to off the top peak of the voltage and lower that down, because that creates a lower temperature and then the viability of a higher clock speed. So it's like I could turn around, and if I was a scam artist, I could just launch new processors, BIOS lock them or firmware lock them very specifically, and then literally change the power curve, and then lower it down and up the amperage and specify the motherboards for it, and that way I could have 5 gigs or 5.5 gigahertz processors, in lieu of the exact same no need to develop anything, because it's there already. So there's no problems with 5 gigahertz processing at the moment. That's perfectly feasible. You may get that on air, but you would probably still end up with the same sort of temperatures as what you got now. I did an AMD Wraith Prism review as well on this. This came with the box with my processor. It was poorly designed. It needs an extra 10% copper on the bottom. your spin up needs changing, so it's about 25% inefficient. So you may need, you can work out how you're going to fix these so that they're 20% better than what they are, because at the moment that's 20% inefficient for anyone wanting to cool their system. So if you enjoyed my poke at AMD and their crap software design and their Ryzen Master, then yeah, do subscribe. We go through quite a bit. I'm an old guy who used to do like high performance systems, you know, the ones that everyone used to go, I want a system like that. Yes, that was me. I used to make them and sell them. They were known as the GT Ultima systems because I used to make very few custom bespoke systems for clients around the world.